Wait, why would anyone design a compass that forgets lengths? Isn't that the whole point? It's one of geometry's weirdest unwritten rules, but somehow it became the foundation of rigorous proof. But this strange limitation isn't just about compasses. It's about what counts as proof in math. And Euclid's answer changed everything. Proposition 2. To place at a given point a straight line equal to a given straight line. Sounds simple enough. We're given point A and separate line segment BC. We need to construct a line segment equal in length to BC with an endpoint at A. Most people would just use the compass to measure BC, then center the compass at A to mark F and draw AF. But if you look closely, there's a move in there Euclid never said we could make. Euclid's compass doesn't remember lengths. Like the legs of a marionette, it collapses the moment you lift it. This limitation isn't inconvenient, it's deliberate. Proof relies only on what's explicitly allowed. Euclid provides 3 rules that apply to Proposition 2. Postulate 1 grants us the ability to draw a straight line from any point to any point. Postulate 2 grants us the ability to produce a finite straight line continuously in a straight line. And Postulate 3 grants us the ability to describe a circle with any center and distance. I didn't technically break a rule. I just assumed something Euclid never said I could do. Most compasses lock in place, but Euclid never gave his compass that ability. His rules don't forbid it, they just never mention it. And from that silence, everything changes. Euclid wanted to build geometry from only what's explicitly allowed, not from what seems obvious or convenient. He creates a world from just 3 creatures. The first creature is a line segment that can be drawn between any 2 points. The second is a ray, which can be drawn from any line segment and continue in a straight line. The third is a circle, which can be drawn from any line segment. One of the endpoints of the line segment is the center of the circle, and the other is its boundary. These are the only tools Euclid gives us. Let's see how Euclid transfers line segment BC to point A without remembering a single length. First, we draw a line segment between A and B. Then, we draw 2 circles, one centered at A with radius AB, and another centered at B, also with radius AB. These circles intersect at a new point, point D. Next, we draw line segments from D to A and D to B. We've formed an equilateral triangle. All 3 sides, AB, DA, and DB, are the same length. Next, we extend 2 segments to form rays. The first a continuation of segment DA, and the second a continuation of segment DB. Next, we draw a circle centered at B with radius BC, the original length we're trying to transfer. This circle intersects the ray at a new point, point E. Now, we draw one more circle. This one is centered at D and has radius DE. This final circle intersects the other ray at a point we'll call F. Line segment AF is our result. It has the same length as BC, but we got there without ever remembering a length. That final segment AF is theoretically exactly the length of BC. Euclid was able to transfer a length without relying on a tool that could remember a length. This unwritten rule might seem like mathematical minimalism, but it's really philosophical. This uncomfortable proposition reflects an ancient struggle. What makes a proof convincing? Euclid wasn't just doing geometry, he was defining how proof works. Every step must follow from something as simple as possible. Without solid foundations, we have nowhere to begin. And without agreement on where to start, we just go in circles. That's why these foundations must be as simple and universal as possible. Only then can everything else be built with certainty. No hidden tools, no tricks, just logic.